So we're going to talk about the principle of identity in Nietzsche's work and in science. So what is the law of identity? The law of identity is a basic law in classical logic, which is A equals A. It's so basic that Aristotle at one point, when he's asked to defend it, he says, well, anybody who doesn't accept this is a plant, right? So it's so basic that this is where you have to start conversation in logic, at least in classical logic. So typically, the way we learned in school was that there's a hierarchy of science. So, right, the social sciences sort of depend on psychology. Psychology depends on neuroscience. Neuroscience depends on biology. Biology depends on chemistry, and chemistry depends on physics. And physics is sort of where it ends. But when we dig into the literature, into the epistemology of science, it goes a little deeper, right? That physics itself depends on mathematics. That mathematics is coherent. And mathematics itself depends on logic. And for logic to make sense, A equals A has to make sense, right? So it's one of the three laws of thought. I'm not going to go into the other two today, but it's the foundation of science when we look at it this way. So there's, right, the old phrase where somebody says, oh, the world is on the back of a turtle. And somebody says, well, what's the turtle on? And he says, well, it's turtles all the way down, right? And that's what is known in philosophy as a regress argument, right? That it goes on infinitely. Now that's a problem because if your justifications go on infinitely, they never bottom out. So foundationalism holds that we have to start with a foundation, and that foundation for classical logic and classic philosophy is A equals A. So right on top of A equals A, we then get logic, mathematics, physics, etc. Right? So A equals A has been the foundation of Western knowledge for over the last 2,000 years. So what is this law? Right, without going into the nitty-gritty details of the actual logic, we can just sort of talk in an everyday way about it. Right? So A equals A means a thing is what a thing is. Right? If you're going to disagree with that, maybe we'll have you checked into a psych ward or something like that. Right? It's very basic. Right? If a thing is A, then it is A. Right? If this ball is red, then this ball is red. Or if this puppy is fluffy, then the puppy is fluffy. Right? So it's a tautology in the sense in which it's true based on the structure. It's analytically true based on the structure, as long as the premises here are true. So let's go into the history a little bit. Excuse me. So we can look at the history of the principle of identity. It certainly starts before, but one of the classic texts that puts forward the principle of identity is Plato. Right? And he puts it forward in the Theaetetus, and Socrates says, first of all, don't you think each of them is different from the others and the same as itself? Right? The same as itself is A equals A. And Theaetetus says, of course. Right? How could you deny such a thing? So this is one of the books that they have here that you'll be able to see after. This is Euclid's Elements from 1482. It's really just beautiful to look at. I encourage you to take a look. They also have here the first translation into English. And it's really interesting that they have like pop-ups in the book, so you can actually visualize the geometry, which is a really fascinating historical point. Right? But the principle of identity becomes important in Euclid's Elements in what is often called, right, common notions. That equality is just one of these basic things that we don't need to prove, right? If A is equal to B and B is equal to C, A is equal to C. So this is a text where Nietzsche gets the idea of the principle of identity from. He quotes it at one point. So where is this important? Where does this become important in science? If we skip ahead from Euclid, we can find it becoming important in Leibniz. Right? Leibniz, who created calculus at the same time as Newton, writes, "The great foundation of mathematics is the principle of contradiction or identity, i.e., that a proposition can't be true and false at the same time, so that A is A and can't be not A. The principle is all we need to demonstrate every part of arithmetic and geometry, i.e., to demonstrate all mathematical principles." So we see, in the history of science, it's foundational, particularly for mathematics. A figure who now we don't know, right? We are very ignorant of him, but he played a really big part, particularly in Nietzsche's thought. He sort of shows the tendency of thought at the time in his work Thought and Reality, where he says, "In the principle of identity, we find the supreme a priori principle of all thought and all knowledge." Now, a priori means before experience, so it's true before experience. So it's the foundation. So moving on from Spur and Leibniz, around the 1850s, we start to see the second law of thermodynamics proposed by these two gentlemen, and they end up getting discussed quite a bit in the text Nietzsche is reading. In particular, one of the hot topics of the day is that, based on the second law of thermodynamics, the universe will come into a state of equilibrium. That is, it will have a heat death, right? That all motion will stop and heat will be distributed equally. So this, at the time, is kind of like what chaos theory was in the 90s, right? Everybody's talking about it. It's that weird stuff going on. So although Nietzsche probably didn't have the mathematical background to understand why these were the case, he read a lot of philosophers and scientists who could, sort of dumb things down for him a bit. So we've got four people who sort of critique the identity of atoms that's necessary to get the second law of thermodynamics off the ground, with Volk, Leibniz, Helmholtz, and Caspari. So we've got a variety of different people at the time that are well known who are pushing forward a sort of critique of identity or a reestablishing, a reapproach. So not only is it these large philosophical issues and scientific issues that are happening, but we're also seeing the problem of identity start rippling in science at the time. For example, in Friedrich's scientific botany, we start to see the problem of identity occur with regard to whether or not species are self-identical. Like maybe individual things are self-identical, but can we talk about that in terms of species? So we also see this in the work of Liebig. In particular, he's talking about copper oxide and how it can gain and lose properties and still be the same thing. Right? So one thing over time that changes properties, but is still identical. We also get Moll when he's talking about vegetable cells. He talks about how the sort of physiological identity of plants that we see, that when we observe, might not be the identity themselves. So we could have two different species that look exactly alike to our eyes. So these ideas are sort of bubbling under the surface. And I want to talk about this, but I also want to say I'm very much not qualified to talk about this. So while I have taken courses on quantum theory, I'm going to explain it as layman-like as I can. So with the double slit experiment, it suggests that light can behave both like a particle and like a wave. So if we imagine a single slit and something to record, and we imagine a paintball gun shooting through the slit, we'd imagine we'd get a line here. And if we did 2 slits, then we'd get 2 lines. But one of the interesting things is that when we do this with light, we first did it with electrons in 1961, I believe, we don't get 2 lines, we get what this pattern is over here, which suggests that the electrons are interfering with themselves. Now, to explain that, I'm going to use the help of some physicists, because that's not what my PhD is in. So, in the 1930s, both von Neumann and Birkhoff suggested that these sort of conclusions actually mean that the old classical forms of logic just don't really apply. So, as originally formulated by Birkhoff and von Neumann in the 1930s, classical logic simply provides the wrong results when we attempt to apply them to quantum physics, right? The math doesn't turn out right. So they suggest that the principle of identity simply can't be taken as a universal law of nature as Plato and Aristotle believed. So if we fast forward a little bit, excuse me, to a book from 1995, it suggested that there are entities, or non-entities, quanta entities, that the law of identity doesn't apply to, right? He says if an entity is a this something, then field quanta are not entities. They lack numerical identity. Now, reading this, you should be like, that sounds crazy. What? But, right, these claims occur again. So another book that we have here, right, repeated again in 2006. And in a fairly recent book by Lewis Peter, he suggests, on this view, the basic ontology presented to us by quantum mechanics is one of relations. And the question of the individuality or otherwise of the relata doesn't arise. One can simply forgo the particle description, right? So we don't need the principle of identity to get things running. We can talk coherently without presupposing it. So Lowell, one of a philosopher who comments on this, puts forward this as one potential way in which we can explain some of the weirdness in quantum mechanics. He doesn't like this answer particularly, but he puts it forward as a possible candidate. He says, perhaps it is erroneous to assume that whatever A may be, there must be an objective fact of the matter as to whether or not A is self-identical. That is, A equals A cannot be assumed to be true. Right? So this quantum physics is telling us something really strange, that the foundation of logic, since Plato, there's a problem with it. So I personally don't want to draw too many conclusions from quantum physics because that's not my area of expertise. Right? And as Lewis suggests, so very little can be concluded unconditionally on the basis of quantum mechanics. The best we can say is that not everything in our received classical worldview can be right. So what most contemporary theorists suggest is that one solid candidate is the principle of identity might not be universal. So that's sort of where we are in contemporary science. So Let's actually get into Nietzsche's argument here. So again, we've had this presupposition that the principle of identity is the foundation of knowledge since Plato, at least. And Nietzsche is very suspicious of any sort of Platonic knowledge. That's knowledge that doesn't come from our empirical study, knowledge that's supposed to be truths based on rational insight, right? It's like, just because you think you believe something and it's undoubtable, that doesn't mean it's undoubtable. That means you don't think you can doubt it, right? So he pushes this critique into logic. In his work Beyond Good and Evil, he writes, behind all logic and its seeming tyranny of movement, there also stands valuations, or more plainly spoken, physiological demands for the preservation of a certain type of life. For instance, that the definite is worth more than the indefinite, or appearance worth less than truth. Such estimates could still be mere foreground estimations, despite all their regulative importance for us, right? Not for truth itself, but its importance for us and our survival. A certain sort of foolishness as may be necessary precisely for the preservation of beings like us. So he wants to suggest, and we'll see him suggest this a couple more times, right, that perhaps the truths of logic and the truths of reason are something that we need to survive and our ancestors needed to survive, and they're very useful, but maybe they're just very useful fictions. So he suggests that our concepts, right, our logic, our rational intuitions are things that we inherit from our ancestors. He writes that the mind, right, our rational capacities, has become and is still becoming that, among countless ways of interfering and judging, the one now most familiar to us is somehow the most useful to us and has been passed down to us because the individuals who, through that way, right, that way of reasoning, had better prospects. That this, nothing about true and untrue. So just because something is useful for the survival of the species does not mean that it is true. So Nietzsche goes so far, and this is where his critique gets really deep, that maybe our belief in identical things, that objects are identical to themselves, is actually a concept that we inherited. So he suggests in Human All Too Human, the belief that identical things exist has been handed down to human beings from the period of lower organisms. So Nietzsche, strangely, I haven't figured out why, he thinks it started with plants. That for some reason, plants have the ability to identify things, and anything lower than that doesn't. Not sure why that is, but it's what he thinks. So, right, if we inherit things, that's not actually a bad thing. That's not a problem. The problem is, what if they're wrong, right? Certainly, animals can be wrong about things. They don't have the sort of rational intuitions that we have. What if we got those from lower organisms? He says, through immense periods of time, the intellect produced nothing but errors. Some of them turned out to be useful and species preserving. Those who hit upon or inherited them fought their own fight for themselves and their progeny with greater luck. Such erroneous articles of faith, which were passed on by inheritance further and further, finally almost became part of the basic endowment of the species. So perhaps these basic ideas, these rational intuitions that we think are undoubtable, unchallengeable, and it's unfathomable to imagine a world without them, maybe they themselves have been passed down from lower organisms. Now, you might hear that and say, whoa, 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 slow down. Are you serious? Right? Like when we think about science and a lot of the things that scientists say, they correlate usefulness and survival with truth very often, right? So if you're having false perceptions, you're likelihood of survival is going to go down, right? That's sort of a generalization, we might say, right? If you're out on the savannah and instead of seeing a tiger, you see a fluffy bunny, that's a problem, right? So, for example, Palmer says, evolutionarily speaking, visual perception is useful only if it is reasonably accurate. Or, to put it another way, like Geiser and Dale, in general, perceptual estimates are nearer the truth, have greater utility than those that are wide of the mark, right? So you can go through, I don't know, 100 people who say something along these lines that are working in science. However, in 2010, and since then, the amount of articles that have been coming out is just obscene. We get a picture of the world that really pushes back on this. So this article came out in the Journal of Theoretical Biology by several authors. Donald Hoffman has actually been doing work collaboratively with a lot of people. And he's at UC Irvine, I believe. He writes, we find that vertical perceptions, that's true perceptions, right, can be driven to extinction by non-veridical strategies that are tuned to utility rather than objective reality. So the perception that is true, the perception that is accurate, can get driven to exist out of existence by the false one, but the one that is false but is useful. So this suggests, they conclude, that natural selection need not favor veridical perceptions. So when they're doing this modeling, this is pretty groundbreaking. So just published like 2 days ago, you could get it. It's getting shipped to my house right now. I haven't read it yet, so I can't tell you if it's good. I'm sure it's going to be great. But he just published this book, right? The Case Against Reality. So why evolution hid the truth from our eyes, right? So being a scientist, he doesn't go into this sort of deep philosophical questions I've been talking about today, but he does give empirical evidence for it, right? And as a philosopher, I can tell you our budget for experiments is a pad of paper, right? So when evolutionary cognitive psychologists actually go out and do this sort of experiments and find the results we think that might be the case, it's really exciting. So what does this mean? This means that contemporary evolutionary cognitive biology suggests that false perceptions can actually be advantageous, right? So among competition, among running away perhaps, this is a very unintuitive conclusion. Nonetheless, this is exactly the sort of conclusion that Nietzsche comes to. He who did not know how to find identity often enough, both with regard to nourishment and to hostile animals, that is, he who subsumed too slowly and was too cautious about subsumption, had a slighter probability of survival than he who, in all cases of similarity, immediately guessed that they were identical, right? So if we imagine an ancestor of ours out in the jungle, if you see a flash of red and black in the jungle and go, that's a tiger, and run away, that might give you an advantage over another one of our ancestors who might have gone, hey, that looks like a pretty flower. Definitely it's not like the tiger I saw a little while ago. So the idea here ends up getting explicated even further by Nietzsche to suggest that maybe these false judgments are actually part of just what makes us human. That's part of our ancestry. Right? He says false judgments are the most indispensable to us, that without an acceptance of logical fiction, without a measuring of reality against the purely invented world of the absolute and the self-identical, mankind could not live. So perhaps it is constitutive of what we are as human that we have inherited these mistakes. So here we come up to our last bit here, Darwin. So Darwin, right, when we read his autobiography, he says, you know, I'm not really much for reading philosophy. I don't like to think abstractly. He says, about the great men of philosophy, Darwin wrote, I knew very little. However, right, Darwin, like most figures, has a very different conception of himself that he wants to portray than what is actually going on. Now, what the archival evidence suggests, based on his reading list, right, he'd make books of what he was reading. I don't know, as an academic, I do that all the time. But in these lists, we find that he's just reading tons of philosophy. Right? For those of you who've taken an intro to philosophy course, you'll probably recognize Hume, right? Locke, another huge empiricist, Berkeley, Montaigne, cut off at the bottom here, but he says he wants to read Aristotle. And notably, he says, I want to read Aristotle because I want to see if he has views like mine, which is pretty interesting. So one of the things that's really weird when I ran into this is that in a letter, Darwin actually expresses the same sort of concern that Nietzsche is putting forward, which, you know, Darwin we think of as a scientist, but this is some high philosophical thinking. He writes, the horrid doubt always arises whether the conviction of man's mind, which has been developed from the mind of lower animals, are of any value at all or trustworthy. Wow. You're like, Darwin said that? Oh, whew, gives me chills. So, let's wrap up here. So we had this idea, this foundationalist idea since Plato, that we start with something like A equals A, like identity, and upon that, we build the rest of Western knowledge. Now, if we don't have that, we might get a little nervous, right? We know what happens when you blow up the foundation of a house, right? Anybody who's built a house knows you have to start with the foundation, right? You can't just leave the house floating on the air, right? You need something at the base. So this should be very worrying. However, right, we can kind of ask, well, if we don't have A equals A, does that mean like everything just explodes, that the world has gone mad and like we can't trust anything anymore? No, of course not. But it does mean that we need to look at science and foundationalism a little bit differently. The foundationalism that worked for Plato and Aristotle, the logic that worked for Plato and Aristotle, doesn't work the same way today. It's not as universal as we once thought. So while we might consider, right, the modern crisis of our times, and if you're hearing about this, you might be like, what are we going to do? Well, we've been dealing with it, right? We've been dealing with it for the last 100 years, right? And we've been dealing with it separately in different disciplines. So, right, in mathematics, they've developed different models for thinking about how our common notions of identity don't actually function when you're doing mathematics and quantum physics, right? We also developed pair-consistent logics that can allow things to be true and false, or neither true or false, right? Obviously, with physics, with quantum physics, we've sort of chucked the idea that the principle of identity is universal, and they can still talk. They can still get around in the world as human beings. We've also developed ways in dealing with this problem in computer science, artificial intelligence, ecological and biological modelings of perception, and also in economic modeling, right? So what seems like, oh my gosh, this crisis, how could this possibly be? Well, we've been coping, right? We've been coping for a long time, and everything has not collapsed. But nonetheless, it's really fascinating to think about the principle of identity, how this was the foundation of Western knowledge, how it came to be doubted, and how we are still today finding workarounds for how to produce science, right? This shouldn't lead us to be science skeptics, right? Science is a very special epistemic enterprise. It gets at knowledge in a special way. And one of the things that it does is it helps to self-correct its basic assumptions. So when I talk to my students about science and where we are, instead of foundationalism, I use the analogy of Nuras boat. And that's that instead of thinking that we're building a house like we're on solid ground, and we start with a foundation, and if you don't have a foundation, the house is going to collapse. Instead, right, doing science is kind of like being out at sea on a boat, and you have to keep plugging all the holes as they come up, right? And it's not like you can go into shore and just be like, well, we're going to scrap the whole thing, and we're going to go in and build a better boat from the bottom up. You're like, no, we're on this. We can't go in. So science itself is not in jeopardy because of this, but when we understand our history, when we understand the history of science, we can better understand science today. So I'll end with one of my favorite quotes from Nietzsche about humans' ability to change, right, and our ability to adapt and change our knowledge in very important ways. He says, stripping off the skin. A serpent which is unable to strip off its skin will perish. So will all those intellects that are prevented from changing their opinions. They cease to be intellects. So that is where I'm going to leave us today, and thank you for listening to me.